Good day everyone and welcome to our Calculus 3 class, where in this lesson we will delve into one of the fundamental concepts of calculus, the mean value theorem. So the mean value theorem is a fundamental result in calculus that connects the behavior of a function with its derivative. It provides a formal way to relate the average rate of change of a function over an interval to the instantaneous rate of change, the derivative, at the same point within the interval. Well, by establishing a relationship between derivatives and continuity, the mean value theorem provides powerful insights into the behavior of functions. And to illustrate the application of the mean value theorem, para mas masabtan nato, we will explore a practical example that demonstrates how to identify a point where the instantaneous rate of change matches the average rate of change over a given interval. And through this example, we will not only solidify our understanding of the theorem but also highlight its relevance in real-world scenarios. So, let's get started. So here we go. So, our example, sige, suppose that we know that fx is continuous and differentiable everywhere. Let's also suppose that we know that fx has two roots. Show that f prime x must have at least one root. So, it could be its solution. Well, it is important to note that all we can say is that f prime x has at least one root. We can say it will have exactly one root. So don't be confused with this problem. This is actually a fairly simple thing to prove. Since we know that fx has two roots, let's suppose that they are a and b. Now, by assumption, we know that fx is continuous and differentiable everywhere. So in particular, it is continuous on, open bracket, ab, close bracket, and differentiable on, open parenthesis, ab, close parenthesis. Therefore, the mean value theorem, there is a number c that is between a and b. This isn't needed for this problem. Well, but it's true so that it should be pointed out. And that, note, if fx is continuous on, as you can see in the screen, ab and differentiable on ab, then there exists a point c is an element of ab such that f prime c is equals to fb minus fa all over b minus a. But we now need to recall that a and b are roots of fx. So, since fa is equals to fb and fb is equals to 0, the equation becomes f prime c is equals to 0 minus 0 all over b minus a. And 0 minus 0 all over b minus a is equals to 0. Or, our f prime x has a root at x is equals to c. Therefore, f prime x has a root at x is equals to c, where c is an element of a and b. Gets ra? Kuha ninyo. Okay. Again, it is important to note that we don't have a value of c. Yes, we have only shown that it exists. We also haven't said anything about c being the only root. It is completely possible for f prime x to have more than one root. And this example day, so kani siya so nakasabot ra kayo. Okay, very good. So this example is a direct application of the mean value theorem. Grabe no. Mapasabot yun ta. Which guarantees the existence of at least one critical point where the derivative of function is 0 given the conditions of the problem. So, mao to siya. And that would be all. Thanks for watching!